Nucleus University, what you are looking at here is what I'm going to call back-to-back dipoles. Now, whether it's 2 particles or 4 particles, I'm not certain. But there's going to be domains that they're going to, and then you're going to have positives attracted to negatives, and so forth. So they are going to create these patterns. See, positive, negative, positive, negative, positive, negative, and they will do it down on the sides as well. And this whole thing is going to be a block of approximately 918 of these. It might be 460 or something, but I'm not certain of that. So somebody's going to have to do this with a supercomputer. This would make a crystallized, literally a crystallized block. And then it would make almost like a square, and then around the edges you would have this sort of a configuration. You see the black is going to hit the red here, so black to red, red to black, same thing over here, black to red, red to black, boom. So it would make this kind of a pinch up to the top. Now, is it stable there? I don't know. What if one of these came up, which was just nothing more than a single photon, and that would have the red to the black to the red, and so forth. Right here, same thing. Boom, you see it? So now we've got this kind of an attachment, black to red, red to black. Now, here's what I'm saying. Now, of course, you got to build a big one of these. And then you're going to have what I'm going to call electron-flooded topography. The outside of this is going to have extra electrons. Those will try to get into the core, but they'll be held around the edge, and then that will create a zone of repulsion to more negatives, and they will stay in that zone surrounding, at a certain distance. Now, what if we impacted this and squished it and popped that out of there, shot it out of there? It would shoot out an exact frequency, let's say. That might be account for the Fraunhofer lines. It might be atomic squeezing, just proposing it. But this is for me, this is the absolute certainty of the construction of the nucleus. It accounts for everything. And all these little extra particles, at a certain number of each atomic stable item, you have to divide out the number of particles and then figure out what the configuration is going to be based on this model, not based on everything's positive. Alright, so you've seen the blocky looking thing. This is really what it would look like. And there's no such thing as protons or neutrons. There's a ball of these things. And at certain numbers, it's extremely stable. Then after that, you have little pieces sticking off like this. Then they can spit off and go out into space. What you get for the Fraunhofer lines, which is a whole series of colors. Colors relate to energy levels of the particles, or in my world, I think it's the size of the particles. And what happens emitted out of here is when something comes crashing in, there's certain sizes of the particles that will hit this, and they will drive off certain sizes of the particles from it. It might be a single, it might be a double, it might be a triple. And that it determines whether it's the different colors, and then you get into X-rays and ultraviolet and infrared and gamma rays and the damaging rays. And then you go into what they call nuclear particles, which is just bigger pieces. That's my world. Fraunhofer lines, nothing more than momentum. You got a whole batch of these in a ball. Alright, you shoot in something of a certain size, it hits this, it's going to drive something off. It's nothing more than momentum. Now, I just want to make a point. That's ionizing radiation. Something comes on here, it shoots this, it goes flying off. That's ionizing. Non-ionizing means it's just shaking in here. It's shaking, but it's not leaving. It's shaking, it's heating up. You know what that is? That happens from microwave radiation. You know what 5G is? Microwave radiation. It's going to come in here and shake these in heat exactly the distance of the particles that are surrounding water molecules. It's going to shake them like this and make them heat like hell. They won't leave, they won't ionize, they won't shoot out of there, but they're going to heat. And that's what they cook food with. on that note, I would come up here and look at 5G devastating update on Mud Fossil University channel. And this is what happens. These things shake. They don't go flying off, but they shake like crazy in their molecular structure. And that results in heat. And the tiniest things on bacteria and that, I don't think it's going to work well for them.